Hello, so today we are going to do this problem, which is part of Leetcode daily challenge. Find if an array can be sorted. So we have an array of positive numbers, and with one operation you can swap any two adjacent elements. But you can only swap them if they have the same number of set bits, which basically means you convert each number to binary form, and set bit is the number of ones in the binary format. And so you can swap two adjacent elements only if they have the same number of the same count of ones in their binary representation. And you can do that swapping operations any number of times you want to, including not do it at all. And the core of the problem is we want to return true if we can sort the array using only these swap operation rules, and false if we can't. Okay. Now for this problem, it's pretty easy. Well, 2, 4, and 8 all have the same number of binary. So if I take, just to show you here, the binary of 2 is 1, has only one value. The binary of 4 has one set bit, and the binary of 8 has one set bit. So all these can be swapped together. So that means we can swap these to be in sorted order, 2, 4, 8. Now what about between 15 and 30? Well, if we look at the binary of 15, it's 4 ones. The binary of 30 is 4 set bits. So we can also swap 15 and 30. So if we do that, within this group, we get 2, 4, 8. And then after that, we get 15 and 30. So it becomes sorted. So we return true because it's possible. This one is already sorted, so we just return true. Now this one, we can sort these ones to be 2, 4, 8, but the problem is between 6 and 8. 6 is bigger, but you can't swap it because the binary of 16 is, no, the binary of 16 we can swap, but the problem is with 3. 3 has 2 ones, but we can't swap it with any of these because these have one bit set. And so we can't really put 3 after 2 because we can't swap 3 with anything. And so return false. Okay. Now you can see here the constraint to the array is pretty small, 100. So it's not too big. Now what's the core idea that we can try to do here? Well, the main thing to realize is what I said here. So the operation we can do is basically we can only swap two adjacent elements if they have the same number of bits. This is the core. Basically is that if there are two numbers that are out of order, but they don't have the same number of set bits, then we have a problem. So let's say we have 3 and 2. Well, this one, we should return false. I can show you here. I think just make this, can I add test case? Yep. So let's just look to add a test case for 3 and 2. Right. So let's add a test case here for 3 and 2. And let's have this just always return true, just to show you. This should return false. So this here returns false because 3, the binary of 3 has 2 bits. The binary of 2 has 1 bit, so you can't swap them. So whenever you have any 1 bit, so whenever you have number with maybe n set bits, let's say for example, and another with m set bits with n different than m, okay, that are out of orders, then we have a problem. Okay. Okay. Which means then basically it's false. We should return false. Okay. But if you have any group of numbers, as long as they have the same number of set bits, we should be fine. If we have 16, 8, 4, 2 in any order, then it doesn't matter. If you have something like this, you can sort this because they all have the same bits. Okay, so how can we simplify the problem then? Well, let's just group by the number of set bits, right? Because any group with the same number of set bits, regardless what's the sorted order, we can just sort it because we can swap in that group, right? So that's the first observation. Now the second observation is that what we can infer from this is that if you have adjacent numbers that don't have the same number of set bits, then basically you can return false immediately because you have no way to put them in order. So observation 2 is that if we have adjacent groups of different set bits out of order, then false, return false, right? Because we can't fix that, right? Because we can't do the swap. And that's pretty much what we can do with this observation, right? Now at the end, if we sort, so what we can do here is basically just take the array and group it by set bits. So in this case, the groups would be 8, 4, 2, and then 30 and 15. So we can take, so this is the group, and then we just look. This one, they have the same set bits, so we can just sort it. So we do 2, so now we have 2, 4, 8. We can do it because we can swap between all of these. They have the same set bit. Of course, we can do it between adjacent numbers, but we basically swap first 8 and 4. So the 8 and 4 first, like this. Then we swap 2 and 8. Then we swap 2 and 4, right? We can do that with a certain number of operations. And then we sort 15 and 30. We swap just 30 and 50. And now we have a sorted order. But this is not enough because maybe this was 16. If this was 16, then we have a problem. Then we should need to return false because 16 and 15 are out of order. So even after we concatenate and sort and concatenate the groups, we need to check if the result is equal to the sorted original array. If it's not, then we weren't able to sort, right? So that's what we need to do at the end. And then the other thing that we can do also when concatenating, even before reaching here, so that if there are a lot of elements we don't do unnecessary work, is just to compare. If the last element here is bigger than the first element here, then we should stop, because these are out of order and they don't belong to the same group of that gives us the same number of set bits, and so we can't swap them, so we are out of order. That also handles this case. And so here we just need to check if res minus 1 is bigger than the, let's call this sorted group, then bigger of the first element of sorted group, then we can return false, because that means we can't really put them in order, okay? And so that's just pretty much so observation 4 is to also check if previous group of set bits is in sorted order with next group, right? Because if it's not, that means we can't reconcile that to be a sorted order. And that's pretty much it. So let's just do these observations here one by one. Let's just write the code for each. So that would be like, here we just need to group by number of set bits, so that can be done in Python with era tools. You can also just do a map where the keys are the number of set bits and the values are the list of numbers. But I can just simplify this and use group by. Now our key function is going to be just counting the number of set bits. Here we just need to check the bit count, and this will give us the number and the group. And then we can just get the sorted group, right? Because this is a group of the same number of set bits, so we can swap them until we get them sorted. So this would be sort group, and let's call this the result final array pretty much after doing the swapping. And then we just need to check if we already added some numbers and the last one is bigger than the first one of this one, right? So we are in a case like this one or a case like this one where we have two groups, 3 and 2. 3 is bigger than 2. So in that case, there is no way to sort, so we can just return false. Okay? Otherwise, we want to add. So this is pretty much observation 2 here. Okay? And then this is pretty much observation 2 and 4. And then what we can do here is just add the sorted group for the next iteration. And then after that, we want to check at the end, just return this. And that should be it. Now this is a for loop in, so it should be in like that. And we can run this, looks good, we can submit, and it gets accepted. Yeah, so that's pretty much it for this problem. Thanks for watching, and see you on the next